In this movie, we'll put together everything we've learned so far in order to create a beat machine application. Let's take a listen. So you could see that we've got a patch that is making a bunch of drum sounds at different rates, which is found over here in the patch. As well, it's cycling around different drum hits, which is determined, the length of the cycle is determined by this H radio, and then the notes in the cycle is determined by this note grouping slider. And so what we'll do is we'll deconstruct this patch, or actually we'll create it from scratch. We'll take a look at how to connect it to Reason, talk about Rex files and how they're sliced up, and we'll make the beat machine from scratch. The first thing we want to do is check PD extended to make sure it is sending Midi out through the IAC driver, which it is. And now we'll check out Reason and go to the preferences. In the preferences, at the top drop-down, we'll choose Advanced Control. And for bus A, choose IAC driver bus 1. What this is doing is it's allowing Midi to flow between PD and Reason, and then we're going to connect the Dr. Rex loop player to the IAC driver. To do that, we'll take a look at the rack within Reason, and I'm using Reason 4 here, by the way. Reason 3 has a bit different interface for the Reason hardware interface, which is at the top, but it's essentially the same idea. What we'll do is we'll click on the Advanced MIDI Device button, and this pops down a window that shows IAC driver bus 1 at the top. So this is how we select different buses. And then channel 1, choose the drop-down and select Dr. Rex in. Now, of course, this is assuming that you've got all of your devices hooked up, which I do. This is a very simple patch. This is a Dr. Rex flowing into a reverb unit, the RV7000, flowing right out to the hardware interface. No mixers, no combinators, nothing of that. The Dr. Rex player has the loop. I can search for a loop by choosing Browse, but I've already chosen one. To hear it, I'll choose Preview. Now, that's the loop played back as it was intended to be played back. But what we're going to do is we're going to take each of these slices and trigger them with Make Note. And to hear them, we go down to the Edit portion and make sure that we're not in the lane view here, but the Edit view. And we'll see slice 1 through, I think, 30 some, or 92. And as I click each of these, I'm accessing different slices in the Dr. Rex. If I click this very, very small icon here that shows Key Edit, I get a conventional piano, and actually find that the lowest sample is somewhere here in the C1 to C2 range. So C1 upwards to about C3. So the idea will be to create a patch that is just sending out MIDI notes from C1 upwards to C3, and we'll actually use numbers for that. And those MIDI notes will come through to Reason via the Advanced MIDI device here on channel 1, Dr. Rex in, and it'll randomly play, or not randomly, depending on how we code it, each of these slices. And since the slices won't necessarily be in the same rhythmic proportion as the original, we're not going to get the original Dr. X loop, which is this. We're not going to actually get that at all. Okay, so the next thing to do is come over to our blank canvas and begin coding. Now, let's take a look at how we're going to trigger the sounds. So we'll create the portion of the patch that will play notes. So we'll need a metro, and ideally this metro will control the entire experience. We'll need a creation argument. For now, we'll use 125, but later we're going to actually create a BPM-based metro. Use a counter, and the counter will help us cycle, because what we're going to do is we're going to cycle through a set of pitches. Okay, now make a modulus. The modulus will determine how many pitches we cycle through. So let's say 8. And then we'll create a number atom so we can take a look at what it is we're seeing. And we need a toggle to turn on the metro. And let's see it. So it's counting from 0 to 7. If I were to hook that straight up to a make note right now, I would be playing MIDI notes 0 through 7, which is not within the range of the Dr. X player. I'll make a make note, 64, and the duration will eventually be tied to the tempo, but for now we'll make it 125, the same as the metro. And make a note out, and I do want to specify the channel 1. Okay, so the notes start around MIDI note 30. So what we'll do is we'll create an offset. We'll take the before the after the modulus rather. Let's create add 30. Disconnect it from the number atom. So now it'll be taking the output of the modulus, adding 30. It'll change the range. So from 30 up to 38. Okay. Let's take a listen. Seems like we've got some notes out of range. I could look up the MIDI note numbers, but I'm not going to bother. Let's say 42. That's kind of cool, actually. Okay, so we've got the first part of this accomplished, which is we're sending notes to the Dr. X. And when we come back, what we're going to do is create a Bpm Sub Pattern that will control the metro and also control the duration of the notes. For BPM, I'm going to create a subpatch that will take in beats per minute based on a quarter note, and have the option to also choose different subdivisions of the beat and spit out a value in terms of milliseconds, pipe it into metro, and then also we'll pipe it into make note to adjust the duration of the notes. So the first thing is to create a subpatch called BPM, so type PD BPM. Okay, this subpatch is going to have two arguments, or two inlets rather. One of the inlets is going to be an int that is BPM, and that's our leftmost inlet. The other inlet is going to be note value. Let's go ahead and comment these. And by note value, we're speaking about quarter notes, eighth notes, sixteenths, etc. So the equation to get BPM is, we'll create a number atom so that we can debug this, but essentially we'll take 60,000 and pipe that into a division object, put it in the left inlet, the hot inlet, because we want any change of BPM to fire the division, and we're going to use a trigger to make sure that happens. Okay, and the trigger bang float is going to happen between the number atom and the 60,000, so that we connect the number atom to the trigger. We send the float coming out of the trigger into the argument of the division to make sure it gets there first, and then we'll bang 60,000 to get the equation. Okay, our result's going to be a float, so we're going to use int to truncate the float, that is to take off the decimals. And we'll give ourselves a number atom at the end to see what it looks like. Okay, lock the patcher and I'll test it out. If I go to 60, I'll get 1,000. So that 1,000 milliseconds is 60 beats a minute. Makes a lot of sense. Okay, so now the next part of the BPM patch will be the note duration. So to do this, we're going to multiply the resultant milliseconds by a modifier. And the modifier is going to be a number based around a center point. And our center point here is a quarter note. So that'll be 1. And then an eighth note is half of a quarter. So that's 0.5. And a 16th note is a quarter of a quarter. That's 0.25. And we'll go one higher. A dotted eighth note is a quarter plus an eighth note, so 1.5. Create a multiplication object. And what we're going to do is take the output of the BPM equation to fire the note value part of the branch, and we'll pipe each of the note value into the multiplication. We'll comment them. So this is a quarter note. And this would change if you determined another note value was your BPM, your basic beat unit. I'm using a quarter note because that's pretty standard, but I could use an eighth note or 16th, and then I would change from there. And this is quarter. Actually, let me change the eighth. That looks strange. 8th and 16th. Okay, now to select each of these, I'm going to use, on the outside of this subpatcher, a V radio. And I'll right-click it, choose Properties. I only need 4 values because there are 4 options. And the V radio is spitting out floats between 0, which is the first one, 1, 2, and 3. Okay, so what I'll need to do here is, when I choose an index here with the V radio, I'll need to fire the appropriate note value and then fire the equation. So I'll need to do trigger bang float out of the V radio. The float is going to go to a select. And the float here is the index being selected in the V radio. So select 0, 1, 2, or 3. Oops. We'll connect the float to that. And now I'll just order the V radio from shortest note value to longest. And so 3, which is the penultimate outlet, goes to dotted quarter, 2, 1, and 0. Let's create a number outlet at the bottom to get the result of the multiplication. And the other side of this particular trigger here is going to bang the BPM part of the equation. So I need to take the left outlet and go into the trigger. And actually we'll change that in a minute because we don't have the inlet for BPM. So I tell you what, let's take all of this. We do need something coming in for BPM, or else we're not doing any multiplication at all because we don't have a value. So let's create a number outlet. We'll store the number outlet in an int. And what we'll do is we will take the bang and put it in the int. Okay, so now the trigger from the V radio is going into the int. Take the output of the int into the next trigger. So this trigger is for the BPM part of the equation. And then we're going to store the BPM in the int. But then this is a critical part that is easy to mess up. What we've got to do is create a bang. We'll store and we'll fire. And I've connected them right to left. I could have used a trigger here too, but don't want to be redundant. So let's say 60 again. Now the equation hasn't fired because I've yet to choose a note value here. And now when I do, you see that the result, this is the result in milliseconds. It's really ms, but I like msec. So as I change the BPM, you see the 16th note, which is the top, is very short. So I'll delete this V radio because I want it on the outside. As well, I'm going to delete this BPM because it's really going to come from the first inlet. And this will go here. Okay, finally, this will do us no good unless we get the data out of the patch. So we need to create an outlet. There we go. Okay, we'll close this subpatcher. We've got our subpatcher cleanly here. We'll connect it to the argument of metro. Go ahead and create a number atom. And for the BPM box, I'm going to choose to create a number box. It's a different kind of number atom. It lets me style it a little more. Right click it, choose properties. Change the width to 3, the height to 24, and the size to 12. Give it a little more presence in the patch. Okay, now I'll create a V radio. Right click it, choose properties. Okay, select 4 because there's only 4 values. And fire it in. Since I just created it, I'll need to fire some arguments there and then choose the BPM. So 60. There we go. And let's create comments on the side. This is 16th, 8th, quarter, and dotted quarter. I'll use my own funky notation for that one. Okay, and this is BPM over here. These are quarter note BPM. Okay, so, and then the result out of this little subpatcher is milliseconds. Okay, so let's fire this thing up. So this is at BPM of quarter equals 60, so we're getting a note every second. 8th notes, 16ths. Well, let's make it faster. So these are quarter notes. 16th. And dotted quarters. So the next thing to do would be to create some control parameter for the cycle of notes so that we could do cycles smaller than 8 notes. We could do maybe 7, 5, or even 1 note cycles, which would just take a pitch and repeat it. And to maybe even consider some sort of randomization aspect of this, and also a controlling of range. The last part of our beat machine will involve creating some sort of interface widget. For the BPM control, we'll use a dial. And for cycle control, we'll use an H radio and a big, large toggle to turn the beat machine on and off. We'll work on the toggle first. That's pretty easy. We'll just do Command 1, toggle. Right click, choose properties, and then change the size to 30. Now, to get this to connect to Metro without a line, a few different ways we can do it. The way that we'll choose is to choose send symbol. We'll call it start stop. Now, instead of the toggle turning it on, we'll do Command 1, receive start stop. And now when we toggle on the Metro, and we're leaving this toggle here just for visual feedback, we see that our beat machine starts and stops. The next thing to do is to use an H radio to control the cycles. Cycles are going to be controlled by this modulo. Let's change the size of the H radio. We'll say size, how about 30? All right. And again, to send this out without a patch cord, right click it, choose properties, and we'll say cycle. How about cycle notes with a capital N? Now receive cycle notes. Okay, and we'll pump this into modulo. Create a number atom so we can see what the number is. And now when we click on the H radio, we see that the number cycle will change. I'll tell you what, let's do this a little bit differently. Choose properties. We'll delete the cycle notes here. Let's create an offset of 1 by adding an addition object. Oops, try that again. And then we'll create send cycle notes. Okay. So now with what we have, we can start the machine. Okay, that's pretty intense, but it's fun. And we'll make a comment. This is the cycle length. And we can change the position of the cycle. So what that means, let's go to the reason window, is that right now we're cycling between a set of notes here somewhere in the C1 to C3 range. So what we're going to do is we're going to take this range of notes we're cycling through and move it up and down. So envision moving through these slices as a group, as a sort of slice group, and moving that up and down in order to get different sounds. So what we'll do is use an H slider, right click it, choose properties, and we'll change the output range to be from 42 at the bottom to 52 at the top. You'll see why we did this in a minute. Change the width. Let's say the width is 50 wide. The height is 24. Okay. And one more thing, properties. Click steady on click. This will make it jump on the click. I know that's a bit counterintuitive the way the buttons are. So I could just jump to a location. Okay, so let's do this, create, try this one, a number outlet. There we go. And so what this will do is it will jump around, and let's go ahead and truncate these floats. And what we're going to plug this into the offset. So take this as a group and create send offset. Okay, now let's make a receive offset, and we'll pipe this into the offset for the addition. Okay. All right, this will become most apparent when we have a cycle of just one, and we move the offset. And if I let it go, it'll cycle. Okay. This is offset. So far we've got a lot of really cool parameters for our beat machine. The cycle length, the rate of the notes, and the offset. And we can do some really great performance things just by using the mouse. And this gives us a nice starting point for the use of any kind of physical sensing or external sensors. And the last part of this, we're going to take a look at using MIDI messages, control messages, to affect the different controls of the Dr. Rex. If we're using a control surface for Reason or some sort of control input in terms of a music keyboard or a UC33 controller or something like that, we can assign the controls by right-clicking them and then moving a fader or a knob. When we're using the advanced MIDI device, it's a little bit different. We have to look into the manual for the device and look at what MIDI channels and controllers we can use in order to control the device. Our goal here is going to be able, or is to use the filter of the Dr. Rex and control that in PD. And so the result will be something like this. Real typical DJ type stuff. So to do this, we will go to the documentation folder of the Reason folder and look for MIDI implementation charts. Now this will bring up a PDF that will give us a big grid of MIDI controllers and how they match up to the devices within Reason. And so what we're looking for in this grid is the Dr. Rex, and that is, I think, a few pages up. Here we go. And it's really, really tiny, so I'll zoom in. So what we see on page 2 is Dr. Rex, and you see OSC octave, transpose, etc. And if we scroll down, there's pitch bend range, which is pretty cool. And let's go to page 3. We see filter resonance, filter frequency. Those are the two things that we want. So if we go all the way over, we want MIDI controller 71, and that's filter resonance, and then filter frequency, that's 1, 2, 3, 4 down. That's MIDI controller 1, 2, 3, 75. So what we're going to do is go to PD, and we'll make the object CTL out. All right. And the controller 71, and the channel 1. So controller 71 on channel 1, and we send a value. For this, we're going to use a slider. So that is V slider, and connect that to the first outlet. I'll go ahead and choose properties and make the height of it a little shorter. We'll send out 0 to 127. Okay, and now copy this entire patch and change the controller to 75. Finally, let's comment the top. And this was filter point. I think the other was Q. I might have them backwards. Q is also known as resonance. Okay, so now if this is working properly, I should be able to see these dials moving within reason. So let me position the two windows so we can see them. So you're looking for this portion of the window up here to be moving. So now as I move this, oh, I've got them backwards. This is Q, and this is frequency point, or cutoff. Okay. Or maybe I have that one wrong. I think it might be 74. There we go. Okay, so now when I play the beat machine, I'll arrange them logically. So now that we can control it within PD, anything that we can do in PD, we can affect the filter and the resonance. And that table was pretty long, so we can actually control a whole host of parameters to get something really expressive using this beat machine in PD.